All right. Algebra 2, lesson 52, using two special right triangles. So we have two types of special right triangles. Keep in mind right triangles. So these are triangles that have a right angle in them, okay? And we're looking at special right triangles, meaning that, yeah, we can make any other kind of right triangle where the acute angles are anything, right? A bunch of different things. But we have two specific types of right triangles that have specific acute angles, that have specific properties that are used to solve a lot of different types of problems when we see these combinations of angles, okay? So some right triangles have particular ratios based upon the angles of the triangle, and they're called special triangles, okay? There are two types. There is the 45, 45, 90 triangle. And the 45, 45, 90 refers to the degrees. Okay? It's really hard with, with this particular program to put in degree symbols. It's not very intuitive. Okay? And then the 30, 60, 90 right triangle. Okay? So just so you understand that those numbers represent degrees of the angles in that triangle. Okay? The measures identify the interior angles of those triangles. Okay? A scale factor, to kind of step aside for a second, is the ratio of a side length in an enlarged or reduced figure to the corresponding side length in the original figure. In these, the scale factor, right? Any 30, 60, 90 triangle is proportional to every other 30, 60, 90 right triangle, because what you have is you have an angle, angle, angle similarity postulate. Okay, so that means if two triangles are similar, then their sides are proportional. So those proportions, or the ratios of the sides of every 30, 60, 90 triangle is exactly the same. Okay, meaning that those ratios will reduce down to the same thing always. Okay, same way with the 45, 45, 90. The ratios of the sides will always reduce down to the same ratio. Every 45, 45, 90 triangle is proportional to every other 45, 45, 90 triangle because of the angle, angle, angle similarity postulate. The trigonomic ratios of each right triangle are always the same. The table that we're going to see on the next page shows the trigonomic relationship of the angles of special triangles. So these are those ratios in simplest form. Okay, here we have a 30, 60, 90 triangle shows up first. Okay, now it could be oriented differently. This is just how we're showing the orientation. But in its most basic format, what we call a unit circle is that what's opposite of 30 is 1. Okay, what's opposite, or what's on the hypotenuse, will be 2. And the side opposite the 60-degree angle is radical 3. That's our basic 30, 60, 90, what we call a reference triangle. Okay, so this is a 30, 60, 90 reference triangle. Does that make sense? Now we could make that a little bit more basic and say that what's opposite of 30 is x. What my hypotenuse would then be is 2x, because the relationship of the side that's opposite of 30 is 1/2 the hypotenuse. Okay, because 1 is half of 2, right? And if this, what we see on the 60 is the side opposite of 30 times radical 3, because what's not in front of, what we don't see in front of that radical 3 is a 1, but it's there, correct? So you could write that as x, 2x, x radical 3, okay? I don't know if that confused you more or less, but this is our reference triangle. So if we were trying to find the sine, which is opposite over hypotenuse of our 30-degree angle, sine is opposite over hypotenuse, right? So what's opposite of 30 is 1. What's hypotenuse here is 2. So the sine of 30 is 1/2. You follow me so far? Okay. The sine of 60, opposite over hypotenuse, is radical 3 over 2. Do we see that? We kind of take it slow. Cosine of 30 from here, which is adjacent over hypotenuse, so radical 3 over 2. Still with me? Okay. Cosine of 60, so starting from 60, adjacent is 1 over hypotenuse is 2. Still see it? Okay. Come over to tangent, the tangent of 30. Okay, so from here, that's opposite over adjacent. So 1 over radical 3, which puts a radical in the denominator, which I can't have. So I'd have to multiply by radical 3 over radical 3. 1 times radical 3 is radical 3. Radical 3 times radical 3 is 3. So it reduces to radical 3 over 3. We wouldn't leave it as 1 over radical 3. Do we understand that? Okay. The tangent of 60, okay, opposite over adjacent is radical 3 over 1. Okay. I don't really need the 1. That should say, sorry, radical 3. Okay. So far, so good. Do we understand 30, 60, 90 ratios? Okay. All right, let's come down to 45, 45, 90. Okay. You'll notice that a 45, 45, 90 triangle is an isosceles triangle because the base angles are congruent to each other. Okay. So, we get tick marks like this. If you remember, trying to think, I think we covered this. Did we cover triangles in here yesterday? No, that must have, maybe it was probably in geometry yesterday where we talked about isosceles triangles. All right, so in an isosceles triangle, the angles that are opposite congruent sides are congruent to each other. Okay, so that's why you see what's opposite of 45 is 1, what's opposite the other 45 is also 1. So what you see is a ratio of 1 to radical 2. And radical 2, if you plug it in your calculator, I think it's like 1.74. Right? Because the hypotenuse should be the longest side of a right triangle, correct? What is the square root of 2? 1 point what? Oh, I was way off. 1.414. Okay? So the hypotenuse is still the longest side. If you come up here to the 30, 60, 90, our ratio is commonly what we call as 1 to radical 3 because it's 1, 2, 3. But if you'll notice radical 3, maybe that's the 1.7. Okay, so radical 3 is still smaller than 2. Okay, does that make sense? So 2 is still the longest side of a 30, 60, 90 triangle. All right, so if we come down here, right, this is our basic reference triangle for a 45, 45, 90. So you want to remember the ratio 1 to radical 2. Up here, 1, 2, radical 3. If you can remember 30, 60, 90 is 1, 2, radical 3, it's kind of easier to remember that pattern because it goes 3, 6, 9. So 1, 2, 3. Even though they're not in that same order. Okay, down here, same, different. So same, different. So 45, 45, 90 is 1, 1, 2. Okay, except it's 1, 1, radical 2. Does that kind of make sense? Something that we could memorize or get down? All right, so sine of 45, it doesn't matter which 45 we go from. Okay, sine is opposite over hypotenuse. So if we come from the upper one, that's 1 over radical 2, right? But if I go from the other, it's 1 over radical 2. It's the same ratio, correct? No matter which 45 I go from? Do you need to? Okay. So 1 over radical 2, we can't leave like that because it puts a radical in the denominator. So what we would do is multiply by radical 2 over radical 2, right? What's 1 times radical 2? Radical 2. What's radical 2 times radical 2? 2, right? So that's what it simplifies to, is square root of 2 over 2. Does that make sense? Am I talking too fast? I know it's a short day and I'm trying to get through quite a bit here. So if we go to cosine, we only have to do it once based upon 45 degrees. And we'll never do a trig function based upon 90. So in a 45, 45, 90, everything is based upon 45. So I only ever have to do it once. Okay? So adjacent, 1 over radical 2, right? You'll see that the sine of 45 and the cosine of 45 come out to the exact same thing. Okay, that's handy, right? Okay, and then we come to the tangent. So what's opposite of 45? 1. What's adjacent to 45? What's 1 divided by 1? 1. Okay? So, well, I don't want to, I won't give you any more. I could go into more stuff and how these ratios work. But, well, actually, I'll do this. Let me see if there's, okay. So let's take a 45, 90. I'm going to put our reference over here. Okay, where it's 1, 1, radical 2. Okay? All right, let's say I'm looking at this 45, because remember, similar triangles are proportional, correct? So let's say I know that this side is 2, has a length of 2. Then what is the length down here? 2. Then what is the hypotenuse? Okay, so let's look at it like this. Okay, I'm going to write a 45, 45, 90 here. I'm going to say that this is x, and this is x, and that this is x times radical 2. Right? Because that's the same ratio. Okay, so if this is 2 here, and this is 2 here, then what's the hypotenuse? 2 radical 2. You got it. Does that make sense? So if this was 3, then this would be 3, then this would be 3 radical 2. Okay? All right? Now, I'm going to blow your bean. Okay? What if I did something like that? Said that the hypotenuse of that 45, 45, 90 is 4. No. How do I get back to the rest of this? All right, so I've got x radical 2 here. All right, let's come back over to this, okay? Let's say I knew x radical 2 and I wanted to get back to x. How would I get rid of the radical 2 to just get x? I would divide by radical 2, right? So if I want to get these other sides, I would take 4 divided by radical 2. Okay, well, I can't leave it like that, correct? Or what do I have to do? Multiply by radical 2 over 2, right? Okay, that's going to give me 4 radical 2 divided by 2, right? All right, can I simplify that? Yeah, and what is that answer? 2 radical 2, which means this is 2 radical 2, which means this is 2 radical 2. So if they ever give you a whole number over here, or anything that's not something radical 2, then you divide by radical 2 to find the other two sides. You see that? Okay. Now, this is beyond where we are today. They're not going to ask you to do any of that, but I just want you to understand the concept of how to get back to the sides. Okay? We could do the same thing with the 30, 60, 90, but I'm not going to because I think that's going to be too much information for today. Does that make sense? Okay. Let's take a look at just a couple questions and then maybe hopefully get into some homework stuff. All right. Okay. Well, this is kind of a similar situation. All right. So let's make our 30, 60, 90 reference triangle 30, 60, 90. All right. Our ratio is really x, 2x, and x radical 3, right? Those are really our true ratios. Okay. So notice that this is 24, correct? So if I want to get x, what do I have to do? What do I do to the 24? Divide it by 2. Because what's opposite the 30 is always half the hypotenuse, right? Because over here, if I take 2x divided by 2, right, I'm just going to get x, right? So if I come over here, I'm going to take 24 and divide it by, and get 12, okay? Once I know 12, okay, what do I do to get the side that's opposite of 60? 12 times radical 3. Okay, so you see how that works? Okay, all right. Now, in this, it's not hard if I know what this is, because if I want the hypotenuse, I just double it, and if I want the 60 side, then I just multiply it by radical 3. The hard part on this one is whenever they give me a whole number for my 60 side, in which case all I do is divide by radical 3 the same way I divided by radical 2 on the 45, 45, 90. Okay? So let's say for a second that we do take another triangle here. Okay, we say that this is 30 here, 60 here. Okay, and I'm going to say that this is 4. Okay, how do I find this and this? Well, like I said, we take 4 and divide it by radical 3, right? Which means I have to multiply by radical 3 over radical 3, right? So I'm getting 4 radical 3 over 3 here, right? So this is 4 radical 3 over 3, and this is, I got to double it. What's 4 thirds times 2? 4 thirds times 2. So 4 radical 3 over 3 times 2 over 1. 8 radical 3 over 3. Okay? You won't get anything harder than that, I promise you, for trying to solve a 30, 60, 90 triangle. If you can remember, if they put a whole number in for a radical side, right? So if my radical 2 hypotenuse in a 45, 45, 90, or a whole number for my 60 side, my, what should be radical 3, then just divide by radical 3 and solve. Okay, I'm going to get my 1 side and then my 2 side. Does that make sense? Okay, so hopefully if you go back and watch these notes, or hopefully even better, you've taken notes today over these examples I've given you. Like I said, I've taught you above what this lesson requires. Okay, so hopefully some of that will help you. Let's look at a question in your book. Okay, because I know it's a short day and we don't have a whole ton of time. Lesson 52. C. Okay, it says use a graphing calculator to find the lengths of x and y. Round your answer to the nearest tenth. Okay. All right, so they give you a 30, 60, 90, don't they? All right, so we're going to put 30 here, 60 here. What's opposite of 30?
We're doing C.
60, that's 40, 45, 45, 90.
Oh, your C is different than mine. Okay. So let me change this up. All right, you're just going to have to tell me what you have. Is it a word problem?
Yeah.
Okay. All right. Oh, okay, so it's giving you that picture, correct?
Yeah.
Oh, okay. So we're seeing where like this is 2.4 feet. Is that right?
Yeah.
Okay. And we know this, all right. And we know the hypotenuse is what, 18 radical 2? Okay. And it wants to know what? Find the height of the kite from the ground. So we want to know, basically what we want to know is we want to know what this is, and then we're going to add 2.4 to it, right?
Yeah.
Okay. Well, that's actually pretty easy because the relationship is 1, 1, radical 2, correct? So what's x in this case? Should be really easy, right? 18. Correct? Okay. So if I want to know this whole height, what do I do? Add 18 to 2.4, right? What's the answer? 20.4 feet. Right? What's crazy about this, did it say use a calculator? No, it didn't. Okay, it says use a graphing calculator. For my C, it says use a graphing calculator, which I still don't, like the only thing that you, on that one, do you have a 30, 60, 90 where it shows you a hypotenuse of 18 and asks you to find x and y? No. Okay, so your book is different than mine. All right, so 20.4 feet is the answer there. Was that really that hard? No, that was a lot easier than you thought it was going to be. You probably just picked it because it was a word problem, right? Okay. Let's see, what time will we get out of here? 10, 11. So I'm going to stop right there. Do we feel like we have a basic understanding of 30, 60, 90, 45, 45, 90? All right. Always remember, 30, 60, 90, our ratio is 1, 2, radical 3. And our 45, 45, 90 is 1, 1, radical 2. Okay, can you look at that chart, write that chart down? All right, that'll help you.